Hi, welcome to the introduction to Edge course ECW ECWO access points. Here's the outline for this session. In this session, we will begin by giving you an overview of our access points. Then, we will cover the key features supported by our APs and the two network types that are available per SSID, which are NAT mode and bridge mode. Then, we will take a look at the built-in tools for analyzing the wireless environment around the AP, as well as built-in logs and reports that are available on the AP. Last, there is an appendix for helping you navigate the AP's web management interface. This will not be covered in this video, but you can check them later in the slides. So let's begin the overview. EdgeCore provides indoor and outdoor access points. These APs may be equipped with different types of antenna. These antenna can be built-in or detachable. Some APs can have all of their antenna built-in or external, whereas some other APs may have a combination of both. Furthermore, these antenna can be omnidirectional, which is good for providing a wide coverage, or they can be directional with a narrower angle, which is good for point-to-point connections. And all of our outdoor APs are IP68 rated. This gives them the ability to provide robust performance even in harsh weather conditions. As you can see, our outdoor APs can operate in a wide temperature range and is well suited for use in extreme environments. Finally, all AP models support at least two operation modes, AP mode and WDS mode. We have just mentioned WDS mode, so let's talk a little more about this mode. In WDS mode, multiple APs can be wirelessly interconnected or bridged based on the MAC addresses of their Wi-Fi radios. This mode can be used if you want to expand the Wi-Fi coverage to other areas, but you do not want to connect these additional APs to the wired backbone. And for this mode, it is required that the APs are on the same subnet and have the same settings for band, channel, and security. Now, let's move on to the key features supported by our access points. First, all of our AP models support PoE, and they can all be managed by the EWS controller and provide enterprise-level wireless performance. And EdgeCore APs also have channel interference detection, so when the interference reaches a pre-configured threshold, the AP will automatically change the channel to continue providing stable Wi-Fi performance. For roaming between the APs, our APs support 802.11r to achieve fast roaming. And there is also Layer 2 firewall, as well as station or client isolation to prevent network attacks. In addition, we have wireless QoS for certain packet types. For example, you can select voice packet as the high priority by 802.11e or WNM. We'll cover this later. Last, all EdgeCore APs support up to 16 SSIDs per radio. Now let's talk a bit more about the key features that we just mentioned. The first feature we're going to talk about is airtime fairness. This is a feature that can mitigate the decrease in performance caused by legacy clients. This is done by giving all clients equal airtime rather than equal access, so that legacy clients cannot take up too much of the airtime and slow down the network as a result. So when airtime fairness is enabled, you have two options. The first option is fair access. Use this option so that all the clients, regardless of standards supported, will obtain roughly the same amount of airtime. The second option is preferred access. This will give 11N clients a slight preference. So with these options, IT managers can increase the overall network performance without sacrificing support for legacy clients. The next feature is band steering. This feature allows the AP to steer clients that can support 5 GHz away from the 2.4 GHz network and towards the 5 GHz network. In general, 2.4 GHz band is more congested than 5 GHz band. So by enabling this feature, you can prevent the situation where all the clients are connected on 2.4 GHz, even though some of them can support 5 GHz. So when band steering is enabled, you can choose the regular mode or the aggressive mode. In aggressive mode, even if the client knew the 2.4 GHz SSID and tries to manually connect to it, the device would still be rejected, and they would only be allowed to connect to the 5 GHz SSIDs. Moving on, there are several parameters on the EdgeCore's APs for optimal client filtering. The first is receiving RSSI threshold. This prevents clients that have poor signal strength, as seen by the AP, from even associating to the AP. So if the RSSI value of the client is lower than the configured threshold, then the AP would reject probe requests from this client so that the client cannot even associate to the AP. Next, if a client has been able to associate to the AP, it can still be removed based on consecutive drop packet threshold and transmission rate threshold. By setting these thresholds, the AP can remove sticky clients that have poor connectivity but still stay connected to the AP. So this can ensure that all clients that are connected to the AP can enjoy optimal Wi-Fi performance. And airtime efficiency can also be enhanced as the number of packets that are being resent is decreased. Multicast to unicast conversion is another helpful feature. It can be enabled so that data can be sent at unicast rates, which are faster than multicast rates. Multicast to unicast conversion can be enabled in environments where the majority of the clients are densely packed around the AP, and if the clients are not using a lot of multicast services. Then we have Wi-Fi Multimedia, or WMM. Our WMM provides basic QoS functionality based on 802.11e. Through prioritizing different types of traffic, Wi-Fi experience can be enhanced. We also support Layer 2 roaming, or roaming between APs, on all the AP models. Just make sure that the SSID for all the APs are configured in the same way, including mapping to the same service zone and having the same security type. 802.11r, or fast roaming, can also be enabled so that clients do not have to re-authenticate when they roam from one AP to another. Our APs support Layer 2 firewall, and IPv4 services can be used as part of the firewall rule. Services are defined with protocol type and optionally with source or destination port. Our Layer 2 firewall supports DHCP snooping, proxy ARP inspection, and isolation between ARF cards, or VAP isolation within the same ARF card. In this section, we'll talk about two network modes that are available for each SSID, or VAP in our term. The first one is NAT mode. So each virtual AP, or VAP for short, can operate as a NAT device with a built-in DHCP server, such that client devices will be assigned a dynamic IP address from the configured DHCP pool on this SSID. After NAT, the source IP address of the client traffic seen by the uplink gateway or switch will be the IP address of the AP. So in this case, it would be 192.168.1.10. The second is bridge mode. In this mode, VAPs operate transparently, such that client devices will be assigned a dynamic IP address from a DHCP server on the LAN side. The source IP address of the client traffic seen by the uplink gateway or switch will remain the original IP address of the client. So in this case, 192.168.1.31. Now, we will introduce some built-in tools for analyzing the wireless environment around the AP. The first tool we recommend using is AP background scan, which will give you an idea of which SSIDs are nearby. So you can see not just the SSIDs, but also their MAC addresses, their signal strengths, and the channels that are being used. So by using the background scan, you're able to avoid using a very crowded channel. So as can be seen on this slide, channel 6 is used by most SSIDs that are detected. So you would want to avoid using this channel on this AP. Then another tool that we would recommend using is airtime utilization diagrams. So airtime utilization diagram can help you understand how much noise is there in the environment. So we have the RX clear rate, the RX frame rate, and the TX frame rate. The first one, RX clear rate, is the percentage of the airtime the current channel is using. Then the RX frame rate is the percentage of the airtime that the AP receives and decreases. And the last one, TX frame rate, is the percentage of airtime from the AP transmitting data. So if you want to calculate how much interference is there in this environment, you can use the following equation, which is interference equals to RX clear rate minus RX frame rate minus TX frame rate. Now let's take a look at the reports and logs that are available on the AP. So if you go to the AP's web management interface, and if you go to system overview, you'll be able to quickly know how the system is doing and see some critical information. For example, its firmware version and build number, as well as how much the device has been running, which is the device uptime. Then you can also see the CPU, RAM usage. And also you can check the radio status. You can see which bands are running, which channels are being used, and so on. Then you can also go to the event log to see the history of the operation of this access point. Then if you want to monitor traffic on this AP, we provide this information per interface. So you can see packet in, packet out, byte in, byte out. Then we also provide real-time graphs, and you can plot the traffic in real time by clicking on the plot button that you can see on the screen. Then oftentimes you want to see which clients are associated to the AP. So you can also go to the associate clients list, and you can see which VAP they're connected on, their MAC address, the RSSI, packet error ratio, idle time, and so on. Then you have the option to disconnect the user, and you can also see their information in real time. Again, there's a button that says plot that you can click on to see information about this user in real time. Last, if you have set up WDS links between the APs, then you can also monitor the link status from the AP. As shown on the right, you can also plot the link status in real time and check information such as RSSI values, transmission rate and speed, as well as receiving rate and speed. So that's all for this session. Congratulations on completing this session with us. If you would like to know more about our APs and see the latest offering, you can visit EdgeCore's website. You will also find a generic user manual for all the APs, as well as a quick installation guide for each model. Thanks again for joining us, and hope to see you soon in the next session.